This is going to be my first YouTube live, and thanks for coming to this session. Myself, Naveen Chatlapalli. I'm a solution architect working at Ashling Partners. Ashling Partners is a technical implementation partners with many companies like UiPath and Microsoft. We implement low-code and to no-code projects, and we are heavy into intelligent automation. Our goal is to become the world-leading number one hyperscaler company. That's about Ashling Partners. More about myself, why I'm so much interested in this topic, you'll get to know. So this is going to be my agenda, and I have given the QR code in every slide so that you can go ahead and download my presentation. Feel free to, just go ahead and put your name and download that. And first of all, I'd like to discuss what, why, and how serverless, and giving some 101 about Azure functions. And what are some AI integration and best practices that we have learned and I have learned implementing a project internally, and a real world demo. But before I move forward, I'd like to present a short story. Once upon a time, there is a developer called John. It's all the days before ChatGPT was even launched. One day, he was working at his startup, and his manager came to him and asked him, "Hey, John, you should be handling a full stack application that we are going to develop right now. It is going to change our company's trajectory, and I want you to handle both the front end and back end." I already have enough on my plate. How could I do all the back end work? That's what John's thinking. But it is promotion time, so he couldn't say no. So he got a small email from Microsoft Azure saying that we will handle your back-end services and you just need to put your code into it, and we call it serverless. That's where John was so excited, he clicked on that link and he started going deep into the world of serverless. So John is like me, and it's like a funny cartoon that I prepared. So Azure Functions and Azure Serverless Functions is a solution that lets you just run the code, and Azure or any sort of cloud providers will handle the back-end portion for you. Just pay for whatever you are running the code on, and just you need to pay for the execution. That is called a serverless. So whatever that is going to be triggered, it can be any event or it can be a gatekeeper that will be updated by your services or operations, and you can run and put your code on that. But why serverless? Okay, John is still sitting and having a pure bliss of having the coffee. But see what Azure is going through: a lot of server racks and keeping the serverless options on 24/7. And also, when there is an automatic scaling of multiple users running onto your front end, it will automatically scale and spike whenever it is needed. And the lazy John is still having a pure coding bliss. That's what and why, this is why you need Azure Serverless for implementation and cost efficiency. That's the major key portion. And let Azure handle the rest of your headaches of your backend. But I would like to say, how serverless? It is going to be a trigger and execute model. That means it is going to drop a file. It can be anything. It can be a HTTP request, it can be a file drop into your storage, or it can be a new queue message. It can be anything. Just lazy John writes his code and puts his triggers on command like a gatekeepers to show me whenever you want to do this, whenever you see something like this, just run my code. And the output can be anything. It can be committed to databases, it can be sending some email notifications, or even it can be some IoT devices, or any values that you wanted to see on your devices. Oh, that's fine. But how did I implement this in my current role at Ashling Partners? So one day, again, my real manager came to me and asked me to fill a bunch of documents which I am developing for a project. Documentation is always boring. I don't want to get into that messy stuff. I want to put my hands dirty and write code, not document all the stuff. Then why don't I use Azure Serverless, whatever that I'm learning previously, into fruition and create an architecture to easily develop my documentation. It can be technical specs document, it can be solution design documents, it can be architecture documents. There will be a set of templates that anyone in your companies will be using for. All you just need to do is download those templates and put whatever the bunch of stuff that you wanted to write. And these days, you don't even want to think. There is ChatGPT, there is Gemini, there is Claude, there is everything. Then I combined all of these things with the Azure Serverless, and I created this tool, internal tool called as Onslaught. It is an AI-powered documentation agent. I will also give you a demo what I have done and developed here. But I just built a small front end where I am communicating my backend to be Azure Serverless functions, and it is running a HTTP trigger. That means whenever the user asks for a documentation and he puts some simple description, says that, hey, this is my project, I'm going to build a project about an automation solution, and why don't you give me a documentation? That is going to trigger my function, which I have already pre-built, pre-written in my Azure, and it is going to communicate with my Azure Open AI services, which I have hosted my model on Azure AI Foundry, and then it is going to convert my stream of responses into a document, and it is going to send me an email. It is saving me a lot of time, at least 8 to 10 hours of time preparing and writing all the documents. So this is why I chose serverless, to automate my needs of creating and writing a document or any sort of documents. So this is how I developed it. Okay, this is me now, not lazy John. I'm going to open a lightweight Next.js application as a front end, and it is going to trigger an HTTP Azure function, which is going to make a call to my Azure OpenAI services, there is a model that I have deployed on it, and then instant documents where I can share it with anyone. Let it be my team member, let it be my manager. Of course, they know that I'm doing this heavy lifting work for them. So they even have motivated me in building and putting more templates into this tool. So we really liked it, and we really loved this tool. And we are also going to expand this kind of implementations to our clients, internal clients too. But you might ask me, hey, why don't you think ChatGPT or Gemini, don't you think they do this? They will definitely generate documents, but not on your own terms, not on your own templates. But this is something that we have uniquely come up with, and we have developed internally, which we wanted to expose it to our clients as well. So I'd like to quickly show you a demo before I go into the Azure 101, Azure Serverless 101. The reason I'm showing you this is to show you the capabilities of what can Azure Serverless functions do, and what are the type of applications that you can create with this, so that you can get a clear picture and you can try implementing it in your own style. So this is a small demo, and this is my application that I have built. This is the lightweight Next.js front-end application. So here, if you see, all I'm trying to do is just put my project description, and I'm going to generate a report type called as test case document. There are multiple report types: solution design documents, architecture diagrams, anything. And I'm going to write my description, and I'm going to give my email. There is no backend. All Azure Serverless is handling it in the backend, and I just need to pay for the execution. I don't even need to get into a subscription model or anything. It is just pay per usage, which is very user friendly for us. If I just type it, and my email, and if I click generate document, all it is taking some time to communicate with my HTTP function, and it is going to convert that HTTP stream into a network memory stream, and it is going to generate me a test case document like this. It is going to just give me an attachment, and it is going to show you like that. So that simple it is. Even just for writing these test cases, my test developers or my test managers will take so much time understanding the concept, understanding the nuances of the idea of automation or anything that we are trying to do, and bring it into a template and bring it into a document. At least this takes some time. What I'm trying to do is just give them some kickstart, and based on this template or based on this ready to go document, they can take this and they can build upon this, where this is a big time saver. All right. Hope you like the demo. Let's go to the next slide, and these are all the slides which will be covering my all Azure 101 things. Consider the Azure functions, whatever that I'm displaying or demoing you here. These are all the building blocks of what you need to mainly understand about Azure Serverless when you're trying to implement some. Whoever in the room know a little bit about Azure Serverless functions? Have you ever tried to implement? Oh, nice. That's good. So you might have some idea, but I'm also going to discuss what are some key things that we have learned while we are implementing this around our projects. So as I told you, these are the building blocks. You should understand about what are triggers and bindings. They are mainly like the gatekeepers of when or how the service is going to get triggered. It can be a HTTP trigger, it can be an event trigger based on any type of events that will be occurred. It can be a blob storage trigger. Blob storage is like a database or some data space where you can drop your files into that storage. It can be a timer trigger saying that, hey, for every this time, like a cron job, run this trigger for certain times or for certain days or certain weeks or a particular day in a month or something like that, and many more. And coming to hosting plans, you should also understand what are the type of hosting plans that you will be leveraging. Mostly for me, consumption plan is much more efficient. But if you are going to do for some enterprise ready and production ready interfaces when you are deploying it for large scale operations, you should be definitely considering premium or flex, which I'll be discussing in the next slides too. Language support. Of course, I am a C# developer in my past, but I also started using Python, which is much friendly, and ChatGPT knows more Python than C#. So I started converting my Azure functions into Python too. But yeah, it supports many languages too, like Python, C#, JavaScript, and you name it. And it is DevOps ready. Of course, you don't need to worry about deploying your service, deploying your functions from your local developer tenant to test tenant to production tenant. So there are some automated build pipelines where you can leverage them and you can put them into any of the tenants that you want. All right, let's discuss about some of the important things that we have learned. While we are implementing this, as I don't want to put some numbers to it, because based on the region, Azure provides you different costs for consumption, premium, and flex plans. These are the three types of plans where you can expect. But as I told you, right, it depends on how you architect your solution, how production critical is that, you should be choosing your plan. And mostly it is having the pay-per execution plan, reserved instances, and it is the combination, flex is the combination of consumption plus burst. That means you reserve your 15-minute capacity or to run your services in a premium mode. Cold start is something that I want to stress on. As I started doing this operations of the internal tool that we built called as Onslaught in a consumption-based plan, we saw some issues of cold start. That means, let's say I don't use the service over the weekend, and if I come back on Monday and if my developers or my teammates want to use this service of Onslaught, which is triggering the Azure function, HTTP function, we used to see some cold start problems that it used to take some time to get it running. So that is one thing that you need to consider. Is it production ready, or if you want it operations to be much quicker, I would definitely ask you to go for premium or flex models. So yeah, the key features will be infinite scaling. You just need to implement the scaling functionalities and turn them on, where you can readily scale them to various number of operations. But the cost also definitely varies on how much your bandwidth is being consumed and how many requests are you getting through this thing based on the plans. All right, I'd like to touch a little bit on event-driven architecture. This is something we also implemented when our storage triggers are not working as expected. That means there are multiple projects that we have implemented using Azure functions, but couple of times when we created a blob storage and we are trying to drop some files, like some JSON files which we wanted to do some code reviews on it, or some image files where we wanted to do some image recognition or some document processing on that. So that blob storage was not particularly able to handle all the services, even though there is a trigger called as blob storage trigger. Then what we understood is there is a particular option called as event driven, and it is going to be a game changer for Azure functions. Like, there is only one instance of blob storage that we wanted to trigger, and every time a file that gets dropped into it, it triggers an event, and there is an event queue that will be created, and it drops that event into that queue, and it works in the first come first serve operation. And that is how this event driven architecture will work, like event publication and event grid routing, and it routes to any services. Like, you don't want to process all the PDF files, there will be a naming convention, certain things, then you can put some event grid routing operations there. And fan out and fan in processings. Fan out processing is mainly considering for multiple triggers parallelly running this operation into various streams and segregating and splitting them into various operations. That is how we also implemented some event-driven fan-out processing architecture. And event filtering, it is like, again, some images which we wanted to filter for recognition or some document capturing. We don't want to consider some sensitive data. So we are also filtering out some PII sensitive data using some event filtering options there. So this is all some sort of trick, event-driven architecture I'd like to touch base on. And one more crucial thing is blob storage trigger, which is also one of the types that we implemented, including with the event-driven architecture, where you have file upload events and the stream processing. Stream processing is something like you don't need to wait. Let's say you have 100 megabytes of video that you wanted to get some analytics on, to run some AI-powered insights on. You don't need to wait for all the 100 MB to be uploaded into that blob storage. So you can turn on the stream processing where it can be based on the chunks. Like, if 10 MB has been loaded, you can start processing your data, and next 10 MB can be segregated into that. So you can split that based on the stream processing. And batch processing is also something like, only if certain number of files are loaded, you will write that, okay, I will start my blob trigger processing. So that is where batch processing will be operated into. Orchestration is again same like fan out, fan in processing. So you segregate and split your operations of your blob storage triggers and understand how you can identify these. Also, I would like to also give some best practices that we have learned, just iterating on what we already saw. The performance, it is going to based upon your architecture that you are going to put on your code. So choose the right plan to minimize the cold start problem, or come up with some creative solution to keep triggering your Azure events even if you don't do that. So optimize your code for a smart catching of your API solutions. Let's say if you are using an API data and how you are catching that information, so you can also think in that way. So that's how you can leverage some performance optimizations and cost optimizations. Definitely, this is only pay for execution. That means also on free versions of Azure serverless functions, you get 1 million of resources for free, 1 million of serverless functions hit for free. and keep monitoring your usage of however you are doing this. And also remember whatever the regions that you are deploying your functions on. Let's say if you are deploying it in West US region, you will be charged a different rate. If it is a East US region or Central US region, there is a different rate. So keep playing with that if you want to get the best rate out of possibly doing this. Security is the most important thing. This is like when we are storing our Azure OpenAI Foundry keys, then we found out that we don't want to expose that externally. So we started using our key vaults, where we don't expose our keys even in the environment variables or anywhere. So we started using some key vaults and best API management practices, something that we learned there while we are implementing some security there. All right, these are some ways that you can start. This is from my Visual Studio. Like these are the two trigger, there are many trigger types, but these are the two trigger types that we previously covered, the blob trigger and event grid triggers. So event grid trigger is something like a gateway. Whenever there is an event that is happening on a blob or on a notification or something, that will be triggered. But make sure this is the naming convention that automatically the Visual Studio will give you a template, but you are good to change that naming convention. Once you publish that function, you will see the same name, event blob trigger. So that is how you match that. You can play around with that, but it is good to have some good naming conventions on this event grid triggers or any trigger naming or function naming there. And in the same way, it goes for blob storage trigger. Once you select the blob storage trigger, the good thing about Visual Studio is it automatically generates a template for you, and all you need to do is run your code there and give the values of whatever the name of your function name that you wanted to give, and whatever the container name that you are trying to give. You can pass them through your variables or some environment functions there. Again, once you publish this function, on the Azure side, you will be seeing the same name like blob storage trigger, which actually gives you the confirmation that your function has been successfully published. All right, this is something new. Previously we tried to implement OpenAI keys directly, but we don't know what OpenAI is trying to target or train our data on. So then we have shifted our focus to Azure AI Foundry, where you can put your safety guardrails of whatever your internal teams or whatever your teammates are prompting about. If there is some sensitive information that they are trying to send out, you can put a block there using this safety guardrails function here. You see the safety guardrails function? Yeah. So that is how you can generate or deploy your model. They will provide you an API key, and all you need to do is, as you are using your OpenAI API keys, just call that API key and the inference endpoint there, and you are good to go. And you can deploy multiple models, large language models. There can be DeepSeek, Mistral, I think Gemini is not available. Gemini and Claude are not available on Azure AI Foundry. Only GPT, Grok models are all available. So that's all. And also the cheapest model on for the GPTs is GPT-4o Mini, which is costing us 15 cents per input tokens and 60 cents per output tokens, which is a great cost there. But I'd like to leave you with my last 2 cents here. When to not use serverless functions? When you are having some high compute tasks and long running processes and some memory intensive workloads and very slow operations, please don't go for Azure serverless functions. So this is something that I wanted to leave you with. But when to use, when is the best case to use Azure serverless functions? When there are some short-lived tasks like my HTTP operation of hitting a point, hitting an execution, and to generate a document and communicating with Azure OpenAI keys, that's where I will use it. And background jobs where there is no requirement of human handling these services, so please go for it. IoT data processing. So think that you want to send some car analytics, like how Tesla does that. When you go and park that in your home, it automatically sends all the information to their central cloud service. So that is how you can do that for your car as well. And real-time stream handling, like how this current operation of live is getting streamed online. So that is the best use case for Azure serverless functions. So that ends my session today. Please feel free to ask any questions.